This is lesson 1 of chapter 5. So lesson 5.1, coordinate plane and interpreting graphs. So we're going to look at graphing equations and inequalities in this chapter. This first lesson starts off with I can identify parts of a coordinate plane just to make sure you understand that where we're graphing things and can find points and things like that. And I can read and interpret data from graphs. So we're going to start doing a little graph interpretation today as well. So the coordinate plane is also called the Cartesian plane, and it has two axes. The x-axis is the horizontal, and the y-axis is the vertical. Hopefully you're familiar with that. Those two lines then intersect at right angles, and they form these four quadrants, and they're typically called quadrant 1, 2, 3, and 4, and they're often written with these Roman numerals, as you see there with the, looks like capital I's and the IV. So the best way to kind of remember the order of the quadrants is the word coordinate plane or Cartesian plane is just to make a gigantic capital C. And as you make that C, you're actually tracing your way through the four quadrants in order. So that's kind of the way you can remember which is which, just with that capital C, okay? The origin is just that point at the very center where the x and y axis intersect. That has coordinates 0, 0. And you can see to the right on the x is positive, to the left is negative. For the y-axis, up is positive numbers, and down is negative. So let's see what you guys can do here with these questions. Go ahead and just stop the video and try and answer all those, and then we'll turn it back on and see how you did. All right, so now a point on the x-axis. I only see one on there, and it is point E. This being the x-axis you see there. This is the y-axis. Name a point in quadrant 2 farthest from the origin. Well, there's two in there. There's J and G, but G is the one that is furthest away. Name a point with a negative x and y coordinates. So a negative x and a negative y would be down here in quadrant 3. So my choices are either F or I. Name a point with coordinates 1, negative 3. Well, 1 is going right 1, and then negative 3 is down 3, and that looks like point C to me. Name a point with an x coordinate of 0. Well, 0 means you've moved left or right 0 spaces, and so you're somewhere on the y-axis, and that would be point B down here. Name a point with a y-coordinate of negative 2. So this is negative 2 on the y-axis. And so anything to the left or right is going to have a y-coordinate of negative 2. In this case, it is F. And what quadrant is H in? Well, H is over here in quadrant 4. Okay, hopefully you did well on those. Let's look at some graph interpretation here. So these, you'll notice that in this drawing, the first thing you want to do when you're looking at graphs like this is figure out what the axes represent. So in each one of these graphs, you see that time is the unit on the x-axis. So this is time is going by as you go further to the right. And then on the y-axis, we have temperature, and so temperature is going up or down, right, accordingly. So if a kettle of boiling water is cooling in a warm kitchen, well, if it's boiling right now, that means the temperature is high and it's cooling, so that is going down. Well, which graph has the temperatures being high and then going down? Well, that would be graph D. Well, graph B is called a step graph, and it would indicate that temperatures are like dropping incrementally, like this is 70 degrees and maybe this is 80 degrees. And somehow the temperature just magically, and in this case it jumps over time, it just jumps right from 70 to 80 instantaneously. Well, that does not describe temperature. Temperature is continuous. In A, it looks like the temperature is continuously rising and falling and rising and falling over time. That does not describe boiling water cooling. In C, the temperature starts out lower, but it's getting higher as time goes on, so that's not it either. And you notice with D, the temperature is decreasing, but it's gradually reaching what we would consider probably room temperature. just how warm is the room, and that's what that temperature is approaching then. Probably room temperature right there, okay? A cyclist travels along a direct route from town A to town B. So this is a little different graph because the x-axis indicates distance from town A, and the y-axis represents distance from town B. So you would think as the traveling is from town A to town B, it's getting further away from town A and closer to town B. So we're looking for the graph where the value along the x-axis is getting larger, and then the value along the y-axis is getting smaller. So if you just pick a couple points here, this one indicates the distance from town A is 0, and the distance from town B is maybe 10, but look what's happening, it's going up. And so like here, you're getting a little further from town A, but you're getting even further from town B at this point. So as the distance from town A is increasing, the distance from town B is also increasing, and that's not what's being described here. When B is that step graph again, it's like you're teleporting, a certain number of feet over, I can't even describe what's going on there. In this drawing, C, it looks like we're starting with distance from town A at this point right here is 0, and the distance from town B is significant. And then what's happening over time is the distance from town B is going down, and the distance from town A is going up until you reach a point where the distance from town A is greatest and the distance from town B is 0. And so that's what we're looking for right there, graph C. This one indicates that as you get further away from town A, you're getting closer to town B, but you never really make it to town B. It's like you somehow missed it on the map. So you kind of went beside it. Your path you took was bad. So it didn't aim at town B. So we're looking at C there. You guys give this one a try. So you get 2 movies free, but then you get charged a fixed rate per movie. So it looks like X is number of movies seen, and the y-axis is total money spent. So what we're looking for is 2 free movies, meaning for 2 movies the cost remains what? 0. If you look at this graph right here, for 2 movies then, your cost is nothing. But then look at this fixed rate, means we're looking at a straight line to represent the cost per movie from there on out. So we're looking at D. Give this one a try. All right. So X is time, Y is height. So this says that you're at a very high point at 0, and you're going to fall to the ground, I guess. You're going to be on the ground after some period of time. Well, that doesn't describe going around a Ferris wheel a few times. So I would think as you go around a Ferris wheel, what's happening to your height, right? As you go around, your height's going up, and then it's coming down, and you're going up and down. So you're looking for this up and down motion. Well, B is at 0, you're on the ground, and then after some time you're at some height, but you never came back down. You were continuously moving upward. This one you're continuously moving downward. And this one you're moving upward to start with, and then you stop moving upward at some point for a period of time, and then you move downward much faster than you moved upward. But then D says, I'm moving upward over time, and then I'm going downward. So I'm going upward over time. Then I get to the top, and I'm going to go downward over time. Then I get to the bottom, I'm going to go back up again, and back down again. And so that's what's happening. That's the motion of that Ferris wheel. Interpreting graphs. So here's some things. I mean, these are probably skills you've practiced in the lower grades, and let's just see how you do with them. You can see the graph over there has days along the x-axis and number of ice cream cones sold over the y-axis. So you always want to look at the title of a graph, look at the axes, and see what they represent, see what the scale of the X or Y axis is. In this case, the Y axis kind of makes it jump to 50. That's what that little squiggly means, is there's some distance there that's not being drawn out. So this one really begins around 50 and goes up to 100. And then we got the days of the week, and they're not in order along the bottom there. That's a little strange, but we're going to go with it. So how many ice cream cones were sold on Saturday? So here's Saturday, and it looks like if I move up the graph, I'm going to end up at 60 right there. For what 2 days were ice cream cones sales the same? Well, there we're looking for, well, I think there's a couple of answers to that. It looks like Saturday and Monday had the same sales. So it could be Saturday and Monday. Or if you look, it says Friday and Wednesday. So you could choose either one of those pairs there. How much did ice cream sales increase from Monday to Friday? Well, on Monday we were at 60, and Friday we were at 100. So apparently people like ice cream better on Friday because that went up by 400 or by 40. Name 2 consecutive days where sales increased. 2 consecutive days where sales increased. Well, I don't see 2 consecutive days where sales increased. We increased on Thursday, but then we decreased again on Monday. They increased on Friday, but then they didn't increase on Wednesday or Sunday. So this is, I would say, none. Okay. What day had the minimum sales? Well, apparently Sunday. People don't like ice cream on Sunday. There were only 50 sold. Okay. All right. You give this a try. Stop the video, answer the questions, and then turn it back on and see how you did. So 1, how much more did the 8th grade raise than the 7th grade in August? So first of all, the 8th grade is the kind of the purple line, and the 7th grade is the blue line, and we've got our months down here along the bottom. We've got amount raised, or dollars, along the y-axis. So we've got $60 up to $80. So how much more did the 8th graders raise there? Looks like $20. For 7th grade, so looking at the pink graph, purple graph, between what 2 months did fundraising drop the most? I would say from August to September it dropped significantly. So August to September. Okay. Which grades saw the sharpest increase during the time period? So where's the sharpest increase? Let's see. Here's a pretty good increase. This goes up 10, 20, 30. This one goes up 10, 20, 30, 40. This one only goes up 30. So yeah, I would say it's probably this grade 7. Which grade? 7th. And when did it occur? November to December. Okay. Between what 2 months was fundraising constant for 8th grade? Well, 8th grade is purple again, so we're looking for the flat space there. You know, I think I answered this one wrong back here. I'm just now realizing it. I think this one was, I used 8th grade instead of 7th grade. So for 7th grade, it dropped the most between October and November. There we go. Okay. Between what 2 months was the fundraising constant for 8th grade? Well, 8th grade is the pink. It's right there. It remains constant. The line is flat. So that means it's the same from October to November. Okay. How much more did the 7th grade raise? Oh, wow. Well, let's see. How much did the 7th grade raise? So we're just going to add these values together and see. So let's go 90 plus 70 plus 60 plus 80 plus 100 plus 50 plus 90. So I see that the 7th grade actually raised $540. So let's see what the 8th grade raised. So 8th is pink, so 30 plus 60 plus 80 plus 30 plus 60 plus 60 plus 50 is 370 for them. Well, that's a difference of $170. Okay, hopefully you got those right. Okay, you'll find a Delta Math assignment on coordinate plane and interpreting graphs, and then there's, instead of a formative, I think there is a PDF posted that you can look at and answer the questions. Feel free to print it out if you want, but the answers are found below at the bottom of that document.